Okay, I hope you can see the slides, everyone.
Very nice.
And hear me properly. So as you just mentioned, I'm currently working as a security research engineer for Proofpoint. Before that, I was defending large enterprise networks for a managed security provider. And before that, I was hunting APT threats in the wild. And yeah, I would like to talk about passive DNS and the advantage of using this technology as a tool for threat detection on the one side when it comes to defending your network, and for threat hunting on the other side when it comes to hunting threats in the wild. Passive DNS often supports daily analysis, hunting and pivoting in many different ways, and it's really a cool tool for defenders, for red teams, for blue teams, for SOC analysts, for every technical person inside the information security business. And I hope you will understand why after I finish my talk. So I will do that by showing you what passive DNS actually is and introduce you into the topic so that everyone is on the same level. After that, I will explain the most common use cases of using passive DNS, and then I will show you 3 examples, starting with a simple pivot, then a more proactive threat hunting technique called oscillating domains, and I will end with a story how we were able to uncover threat actor infrastructure from an APT group. I have to make sure that everyone has a basic understanding what passive DNS is. So that's why I would like to introduce you into the topic quickly. What is passive DNS? Passive DNS is a partial view of data that is available in DNS and gets stored in a historical database. And you can query on that database. This is done by collecting cache misses using multiple sensors on the internet. So this means that real-world traffic can be monitored. The technique was invented by Florian Weimer in 2004, and there is a paper at first.org. If you're interested, you can find and get all facts about the history of this technique. Where can you get passive DNS? There are many different vendors, and a lot of them are offering free and commercial packages, and you're always limited to the quota of queries you can make against the passive DNS database. For example, there is RiskIQ, which is formerly known as Passive Total, or DNSDB from Farsight Security, but also VirusTotal and the Circle in Luxembourg are offering passive DNS services, and I guess a lot of more vendors are doing that as well. So you have different vendors that are offering the service, and that's also a reason why you have different databases. So if you using different vendors, you use different sensors and different databases, and you will therefore get different results. So it's probably the best to use a combination of 2 or 3 services. And as I just mentioned, you can always get a trial or a free version. So I would recommend to you just try it out. What kind of people are using passive DNS? I mentioned that it's usable for first-line defenders, for SOC analysts, for incident responders, but also for threat hunters and for red and blue teams. So every technical person in the information security business could have advantage using passive DNS. Why? And why is this technique useful? What can you do with passive DNS? Passive DNS gives you answers to many questions that are mostly impossible to answer in a different way. And in the next slides, I will show you why that is. What does it look like? On the picture, you can see 2 passive DNS observations for the FQDN proofpoint.com. On the left side, an A record, and on the right side, an AAA record. A record is the answer for querying for proofpoint.com, and you will get in the R data fields, which I can mark, I guess. Yes, in the RData fields, you can find the IPv4 addresses for your FQDN proofpoint.com. On the right side, you can find IPv6 addresses in the RData field. That's why the RR type is AAAA. There is a draft for common output formats at IETF. You can find the link below. And it suggests us that this JSON format should be the standard for passive DNS observations. You have mandatory fields and optional fields. All fields you can see on the slide are mandatory except the count and the bailiwick field. And there is also an additional value that is optional. It's called sensor ID. If you want to divide passive DNS observations by various sensors, it's probably best to define that by using the sensor ID field. How do I use passive DNS? I divide passive DNS into two frames of reference, the internet and the intranet passive DNS. The combination of both points of view makes passive DNS such a powerful tool. So there are two sides of the coin. The external so-called internet view has real-world traffic because it collects passive DNS data in the internet. You can query databases from various vendors, and you can do threat hunting in the wild. On the other hand, you have the internal so-called intranet view. If you set up a passive DNS database in your internal network, you can query on traffic that actually happened in your network, which is pretty cool. So how to build up your own database? You can do that by also collecting cache misses on your DNS servers, or you can do that passively with an IDS system. And if you want to know more about that, you can contact me after the talk, because I've set up my own passive DNS collection in my network using Suricata as IDS and collecting the DNS data from it. In your internal passive DNS database, you have, of course, internal and external hosts, because you also see systems talking to each other and making DNS queries to each other, and not only seeing DNS traffic from a client to the internet, but also from your internal applications. So also from machines that are not speaking to the internet world. This could be really helpful and a powerful tool for threat detection. For example, if you enrich your data that or alerts from your IDS system, and you can also do retro hunts. You can answer questions like, did I see this domain before in my network? Even if your DNS logs are outdated already, because your passive DNS database can store a lot of more data than your Splunk probably can do, or your CM solution you're using. To demonstrate and underline the previous points, I want to show you some easy pivots that are possible for both sides. At first, I want to start with the internet and external pivots. So probably every one of you has done that before and pivoted from a domain to its IP addresses with passive DNS, and in this way you can get a historical overview of the domain resolutions and to which IP addresses your domain has resolved in the past or during the time of the attack. But you can also do that the other way around and pivot from an IP or a whole IP subnet to a domain name. You can also get all subdomains for a domain, which could be a good starting point to support your daily SOC analysis. If you have a suspicious domain, start by getting all subdomains for it. Another thing is you can get all known name servers for a domain by using NS DNS records, or you can also get all mail servers of a domain by using MX DNS records. This could be useful if you have a suspicious domain. You can pivot to its name server, and then you can see what other domains are using the same name server, and maybe those domains are related to the attack you're seeing. I can tell you or show you a lot of more examples, but as I just mentioned before, you just need to play with it, and it's a really, really cool tool. On the other hand, you have the intranet and the internal pivots. You can do the same pivots as before, but with the difference that in your internal passive DNS database, that there you only have data that actually happened in your network because you're querying your internal passive DNS database. You can perform retro hunts there. You can answer questions like, when did the first system in my network resolve to that domain or resolve that domain? Have we seen this domain before in our network? You can also try to detect anomalies if you decide to also store malformed and invalid DNS data in your internal passive DNS database, because some malware and some actors are using binary data in DNS TXT records for C2 communication. And those invalid TXT records are not in external passive DNS databases, but if you set up your own, you need to implement custom parsers for those TXT records, but you can store the binary data at least, and then you can query on it. Another cool hunt is also the client IP to hostname mapping by using so-called pointer records, PTL resource records from reverse lookups. On the slide, you can find such a pointer record for the IP address 10.0025. And a pointer record looks like this over the network, and it gives you the answer Konstantin MacBook.fritzbox, which is probably the host name of my MacBook I'm talking to you. And in this way, if you query your passive DNS database, you can match your client IP to a host name because it's stored inside such a pointer record. And such pointer records you can see such pointer records a lot in internal and private networks, and that's why it's pretty useful as a pivot for your internal passive DNS database. So we have the basics now, and then let's demonstrate all that in a small example for two simple pivots. I've chosen an example that should demonstrate both use cases, the external and the internal pivot. And all starts with an ET-Pro network signature that fires on an HTTP C2 beacon, in this case from a commodity Android malware. And the rule was firing on the victim data that was decoded in the URL parameters. And you can find the beacon on the slide with the red marked C2 domain. On that, we will focus our research. We will first pivot externally for the red marked C2 domain with the purpose to get more indicators of compromise, so-called IOCs, related to this malware infection. And after that, we will search internally for the infected client IP address to identify the host name of the machine. Both use cases should demonstrate you how passive DNS increases the huntability of the threat, because we only have this C2 beacon for one connection detected in our network with our IDS system. But with passive DNS, we can get a lot of more things we can search for in our logs. The table on the slide shows you the results for a passive DNS query for the RR name of the C2 domain. You can find 5 IP addresses that are or have been resolving to our C2 domain. On the slide before, the C2 beacon only fired on one connection. So you only had one destination IP address for that connection. And now we have 4 more IP addresses that we can look in our logs or do retro hunts. What is also cool, if you look at the last row to the IP address ending with 123, you can see at the time first and time last values that the domain has only been resolving to this IP address for probably 1 week in August 2018. So we would have completely missed that IP address if we have not been querying our passive DNS database. Continuing with our goal, now we've done the external pivot, we will do the internal pivot and try to connect the infected client IP address to its host name. In this case, the client IP address was located in a DHCP guest VLAN subnet. And if we query our internal passive DNS database, we will find pointer records from reverse lookups for that IP address. We were also lucky, if you see, we detected 2 pointer records and we have a time interval of probably 1 hour between those. And the timestamp of our alert for the initial Suricata C2 beacon fits perfectly into this time frame, and therefore we could say that the host name of the infected client IP address was Alice MacBook during the time of the attack. Now you're probably asking, how could that happen? Because we have an Android malware and the host name is Alice MacBook. Apple and Android are not fitting to each other. And the funny story is that in this case, the mobile phone was connected via USB to the MacBook, and therefore the host name makes sense in our logs. Continuing with our second example, which should demonstrate a concept how to proactively perform threat hunting with passive DNS, so-called oscillating domains. The idea is to find domains that switch between RFC 1918 private IP spaces and public IP space. I call this behavior oscillating because it's going up and down and yeah, like an oscilloscope. Oscillating domains could be malicious, suspicious, or maybe at least interesting to have a look at, because such domains could be parked by an operator, or they could be sinkholed by security researchers or network admins, and maybe there's no public report about it so far. So they are at least interesting to have a look at. Step by step, how can this be done? You first need to identify such domains by getting all A records, and with a private IP address as our data value, you can query a passive DNS database about that. Afterwards, you try to look for the domains you are getting if there is more than one valid A record for the domains. And then if you have the oscillating behavior, you check the time intervals if they also fit, and then you have an interesting domain. With those domains, you can hunt for more IOCs again, and you can do retro hunts and look back into your logs and see if a system in your network has connections to that strange oscillating domain you found. Now it's getting exciting, because the last example will show you how powerful passive DNS is for hunting APT threats in the wild and uncover their infrastructure. The actor I'm working on for almost a year is called APT32 or Ocean Lotus, and I've prepared a background slide for you on this actor. I will sum it up a bit. It's attributed to the Vietnam state. It targets mostly Asia, but lately also West countries. And there's a new focus on automotive companies. Maybe Vietnam should build a car in the future. I'm not really sure. They have a highly variable toolset, and they're using various protocols for C2 communication, including DNS. So there is a backdoor called Agent Rui, and I will show you a weakness in the DNS infrastructure of that backdoor, which is a pretty cool pivot and a really cool hunting technique. First, we need to get a sort of understanding what that backdoor is. Agent Rui is first mentioned in an asset report from 2018, and I will not go into details. I will just mention the most important step in this talk, but you can read the whole report from asset or ask me if you have further questions. Agent Rui has several C2 modules and supports more than one protocol for C2 communication. It can communicate over DNS, it communicates over TCP and it communicates over HTTP. It has 3 hard-coded C2 domains. At first, when it gets installed, it makes a specific DNS query to get the real server IP address, and this DNS query has the encoded computer name of the infected machine inside the subdomain. You can find an example on the slide for the C2 domain dvaduong.com. There is the computer name randompc decoded in the first subdomain. You can use the generic regular expression below to find such domains, and then you can use a Python script to decode the computer name from the subdomain again. The DNS module gets the real server IP address in its first command, but after that, Agent Rui can communicate over various protocols and also over DNS as a C2 protocol. And we found out that the answer IP addresses for the following beacons are not always the real server IP address, but they are also communicating with the answer IP address in the first 2 tuples. So this is an indication that you can have also overlap between the answer IP addresses, and they use them more than one time. To go further, we need to understand what a so-called start of authority resource record, a so-called SOA record of the DNS protocol is. You can see an example on the slide, and such an SOA record is a type of the DNS protocol and contains administrative information about the zone for zone transfers. DNS name servers are set up as clusters in the internet, and they synchronize the databases with zone transfers, and this is happening with SOA records. In such a SOA record, you can find, for example, the email address of the administrator and a serial number of the SOA record, which should get incremented with every change of the zone. APT32 doesn't do that, so there is an anomaly if you look into the SOA records for known APT32 C2 domains. You will find that if you query the plain C2 domain, as you can see on the slide, you will get a serve fail, so no answer for the SOA record. But if you query a not existing ABCDEF subdomain before, you will get an answer from the SOA record. Why does this happen? There is an information leakage problem on their C2 servers because, as I just mentioned, the computer name is encoded in the subdomain, and they need to accept every request or subdomain because the encoded computer name could be everything. So they need to reply to everything. On the slide, you can find red marked static patterns for the host master and the serial number we found. So Gotthold and 2006-0909 is a static pattern, and there are 8 of them, and we found them in a lot of their C2 domains, and that's a cool step you can hunt further. So I will try to explain the theory in a few words. We have found that this anomaly is not only present for Agent Rui C2 domain, but also we think that APT32 uses this anomaly or for other C2 domains. So I guess they use the same script for rollout of the C2 infrastructure, and this SOA anomaly is always present. As I mentioned before, the answer IP addresses are not always valid and used multiple times. So the idea is to identify more C2 infrastructure by querying for known C2 domains and extract all IP addresses from our data fields, and then query for all that IP addresses and get more domains and validate those domains as an APT32 C2 server by an active SOA lookup and check if the SOA anomaly is present. By doing that, you get 8 different hostmaster serial SOA record pairs. You can find them in the first picture on the slide. And we've started with less than 50 known C2 domains, and we were able to pivot to more than 250 domains at the moment, only by using passive DNS enrichment methods. So this means that we have now a bigger forensic landscape view for this actor and can get more beacons, more rules, more malware that we are able to analyze. What we also found in the passive DNS data are a lot of decrypted computer names that have done this first initial DNS query to the C2 server. And I tried to decode one of them, which could be probably an email or related to the Ministry of Finance of Vietnam. And it's an open question. I'm not sure how realistic is it to identify victims with this method, because you only have the host name and then you have to guess the company or the institution that is behind that. It's not a hard pattern. What is also cool is that if you get the whois records for all the C2 domains and look at the registration dates and underlie Indochina time, and heat map that on a weekly basis, you will get this picture. So this picture shows that the APT32 domains get registers nearly in a weekly work time table from 9 to 5 in Indochina time. And I don't like attribution, but yeah, this picture fits into the pattern, and maybe it's a small clue into the broader overview. So I've talked a lot, but now I want to leave you for today by summing everything up. So at first, passive DNS is a really cool tool, and you can do easy pivots, and they are really helpful. So you can go start with an IP and get all domains that are resolving to it. You can also do it the other way around. You can get all subdomains for a domain, and so on and so on. You can use that for threat hunting in the wild with real-world data by querying external passive DNS databases to hunt for APT groups, to enrich your data and get better overview of an attack. And that's not the only thing you can do, because you can also use passive DNS for threat detection and investigating an incident internally in your network by building up your own passive DNS database in your organization, which can help a lot. And then you have the possibility to search data in your logs and yeah, get an overview of what's going on. So that's it. I will be open for questions if you have some time left. And yeah, otherwise I will try to answer them in written form.
Nice gratuitous suricata picture there. Very nice. So really great job. Thank you. Passive DNS is a very powerful tool, and you've laid out the details of how it works and some of how to do it. And I really like the examples that you drove down to the application of it, particularly with APT32. You bring up that you're doing your own passive DNS with suricata, and just wondering, can you tell us a little bit more about your setup? How did you set it up? How hard is it to set up? Is there something online where people watching here can go get a step-by-step instruction list, or what?
Yes. So suricata has a DNS parser, and you can define that you want to have all DNS queries and answers in your logs. Then you have a JSON format, if JSON output format, with all your DNS logs. And in my former company, we wrote open source tools that can parse this format and push all DNS observations in a customized passive DNS database. So I can send you the links. It's a pretty cool tool. It's like three open source tools connected together, and you have your passive DNS database.
That'd be really cool.
And the output format is then aligned to this common output format. So you can also include an public passive DNS database. Then you have one tool to query, and it queries all other tools.
Okay. Looks like Johnny, the previous presenter, also asked the same thing. Basically, if you don't have PDNS at work, where would you start from? It's a slightly different question, actually. Where would you start from to implement it? So maybe you start from Suricata and an open source tool that you provide, or would you recommend some other path for a more commercial environment?
At first, I would recommend to start by using passive DNS from external vendors, because it's free. It's only limited by the quota of queries you have a day. And if you like that and you want to increase your quota, there are always ways to get help from the passive DNS vendors to set up collecting passive DNS data from your network. And if you share your passive DNS data, you will get access to the whole database of the vendors. So at first it's free, and then you have to pay, or you have to share your data. So that's like the business that's going on. But yeah, every vendor has a free version. So I started with trying out all of them, and then I ended up with using all of them, because I really recommend by using multiple vendors and not only one, because they have different sensors and different databases, and you will get the whole picture when you query all of them.
So is this just a Google search, or is there a place to look? Do you have a list of passive DNS vendors that you recommend?
I also have to paste the tool. There was a recent publication for an open source tool that queries all the vendors.
Feel free to paste that into the
yes.
noob track channel in Discord.
I will do that afterwards.
That'd be great. Wonderful. Any other questions? Looks like that's the only one at the moment. That was a very good presentation. Appreciate the technical content and you drawing it down to real world application. I really like the fact that you didn't say, hey, this is attribution, but rather called out that attribution's hard, but rather giving ideas and maybe percentages of confidence to each idea.
Thanks. I also have to thank Carol, who has helped me a lot with my presenting skills. So the coaching was really cool, and I appreciate that you had me here. I liked it.
Excellent. Well, thank you so much, Konstantin. Appreciate having you here. Thank you for putting it together and for working with Carol. She is pretty awesome.
Thanks.
And we will be closing out the noob track in another 15 minutes with Kamel. Kamel talking about Bluetooth and automotive and why we need to study Bluetooth more. We'll take a break for about 8 minutes or so, and we'll start back up around 5:40, and we'll carry us on into the final keynote with Dave later. So again, thank you again. I will chat with you later.
Bye.